In this video, we'll talk about position and reference frames. Speed, distance, and time didn't require us to define where we started and where we ended up. They just measured how far we traveled and how long it took to travel that far, or the rate at which we traveled. All of those things are called scalar quantities. However, much of physics is about knowing where something is and how its position changes with time. A reference frame lets us define where an object is located relative to other objects. For instance, we can use a map to compare the location of different cities, or we can use a globe to compare the location of different continents. In this course, we will be solving problems in one dimension. We'll also be working in 2 dimensions later on when we talk about projectile motion. Typically, we use the x-axis for that direction when we're talking about 1D problems. We could have vertical problems, though, in which we talk about free fall. The plus x-axis is to the right. The minus x-axis will be to the left. And remember, we've defined the direction going to the right as being I hat, and the direction going to the left as being negative I hat. We can define it the opposite way if we need to, but unless we specify that, we have to assume that going to the right is plus x and going to the left is minus x. And in this case, for position, we're going to be using the symbol x. Now here's a problem. The position is a vector quantity, so we have to put a vector sign on it. And keep in mind also that this is only for when we're in the x direction. If we're doing a vertical problem, then we use y. All of the following are examples of positive direction except which one? Go ahead and pause the video if you need to. Okay, hopefully, you chose C. West, remember, is a negative direction. All of the following are examples of negative direction except for which one? Hopefully you chose A. To the right would be a plus direction, not a minus direction. In the next video, we'll talk about displacement.